Here's an interesting question. Now if we were to take these molecules, H2O, ethanol, CH3, CH2OH, and ethoxyethane, which is an ether, CH3, CH2O, CH2, CH3, what we find is that the boiling point decreases. Going across. Now if we take the corresponding sulfur compounds, H2S, CH3, CH2, SH, CH3, CH2, S, CH2, CH3, the boiling point actually increases going that way. And why the difference? Why the big difference between those two when all that you're doing is changing one atom for a very similar atom just below it in the periodic table? And the difference, of course, is due to the fact that oxygen there is the second most electronegative element in the periodic table. So what we find is that water will form strong or relatively strong hydrogen bonds, and so will ethanol. Ethoxyethane will not, but because there's an electronegativity difference between oxygen and carbon, and it's a kind of V-shaped molecule around the oxygen, we have dipole-dipole interactions there. Now what about these two? Hydrogen bonding there, hydrogen bonding there. Why the decrease in boiling point for ethanol? Well, ethanol has two lone pairs of electrons, just as on the oxygen, but it only has one hydrogen bond that is available to, one hydrogen that's available to hydrogen bond, whereas water has two hydrogens available to hydrogen bond. So greater probability of hydrogen bonding, or a greater number of greater probability of forming more hydrogen bonds than the ethanol. Therefore, overall, you're going to find that has stronger hydrogen bonding overall, and therefore a higher boiling point. Now, in the case of the sulfur compounds, on the other hand, it's a slightly different affair. We find that sulfur is a lot less electronegative than the oxygen, and therefore will have less of an effect in terms of bond polarity. The overall process that we can think of in this particular case is the increasing size of the molecules. So we're increasing the surface area, if you like, of the molecules, and therefore increasing van der Waals. Forces. So therefore, whereas the intermolecular forces decrease with the oxygen compounds, the intermolecular forces increase with the sulfur compounds.